Today we're looking at linear programming. And linear programming is a method used to find a minimum or maximum value given a list of constraints or limits. So for example, if you notice, I have 4 limits or constraints that we're going to actually graph. That's going to make what we call a feasible region. And our feasible region will be tested by this objective function, the p equals 2x plus y, to help us find a maximum value using the vertices of the shaded region. So the first thing that you have to do is graph all of your constraints. And you want to make sure that they're all in slope-intercept form. So for the first one, we have to subtract x and then divide everything by 2. And then for my second one, we have to subtract x and divide by negative, so don't forget to flip the inequality. And then the last two are ready to graph. So I'll do the first one in blue. And it's good to use graph paper with these because you're going to have to get the vertices. So I'll start the first one at 2.5. I'm just going to go down 1 over 2. Down 1 over 2. You get enough to make the line. And then that would be everything less than. So you'll shade below the line. But I'm going to wait. And I'll just miss this whole line. Then I'm going to do the second one in pink. So I'm going to start that at negative 2. Up 1 over 1. Up 1 over 1. Up. And then this will be everything greater. So you would shade above that line. And remember, I'm going to wait. And then for x is greater than or equal to 0. That is a vertical line. So I'm going to make this one really dark. And then you would shade everything to the right. I'm going to wait. And then y is greater than or equal to 0. It would be this line. And we would shade everything greater. So with the linear inequalities, the region where they all meet, get a color. Will be this region right here. And I usually use a highlighter to darken this area so you'll know. Okay? Once you find your feasible region where all your colors would blend, then you're going to name all your vertices around that region. So I have 1, 2, 3, 4 vertices. So that would be 0, 2.5, 0, 0, 2, 0, and 3, 1. And if you don't use graph paper, what happens is you can mess up your vertices. So you want to make sure you try to use graph paper to help you when you're looking for all of your vertices. So what you're going to do is take these vertices and plug them into your objective function. And in this case, they want a maximum value. So you're just going to plug in each x and y coordinate. To figure out which one of these is going to give you. When they say maximum, that's the largest value. And with each problem, your objective function is different. So don't think that this will always be the same objective function. Okay, so for the first coordinate, if we plug in x and y, we're going to get 2.5. For the second one, we get 0. For the third one, we're going to get 4. And for the last one, we get 7. So that means that P has a maximum value of 7 when x is 3 and y is 1. So 7 would be our maximum value. So that's what you're going to do. Graph the constraints, find your vertices, and use your objective function to find out if they will. And you have to look because sometimes they're going to ask you for the minimum. So if they ask you for the minimum value, it would have been 0. So each time your constraints change, your objective function will change, and your whether or not they want a minimum or maximum may or may not change. So let's try another one. Okay, here's the second example. And we're going to do the same thing, make sure all of our inequalities are in slope-intercept form. So for the first one, I'm going to subtract 2x. And for the second one, I'm going to add x. And then the last two are ready to graph. So I'll graph each one. So the first one will start at 6, and my slope is -2. And then we would shade everything less than a line. I'm going to wait again to shade it. And my next one is at 3. And then this slope is 1. So that line would be this way. we would shade everything below. And then the next line is a vertical line at 0. And we would shade everything to the right. And then my last line is a horizontal line at 0. And we would shade everything above. So my feasible region I'm trying to get it'll be this area right here. So my vertices would be 1, 2, 3, these 4 points, which are 0, 0, 0, 3, 1, 4, and 3, 0. You're going to do like the other example and plug these into your objective function. Be careful for that negative. The first 2 functions didn't matter because x was 0. Okay, for the first one we get 0. The second one we get 9. The third one we get 11. And the fourth one we get -3. So this time they want the minimum. So our minimum value would be -3. And that's how you do it. So you graph your constraints, you find your vertices, plug them into your objective function, and make sure you look to see if you're finding the minimum or maximum. And that's it.